In today's tutorial, we will try to solve the problem how to get the transformation done from this highly functionalized bicyclic system with an iodide and a lactone moiety to this monocyclic system, a tetrahydropyrrole functionalized with a carboxylic acid and here an olefin. Please try to solve the problem first by yourself and then afterwards listening to the explanation. So, how should we start to solve the problem? Just comparing these two structures, and then we will notice that nothing has changed in this area. Also, the stereochemistry here at these positions has remained the same. Here, an olefin has been formed, and for the formation of the olefin we need an elimination. But in this case it is not a standard normal elimination. A reductive process has to take place. It's a reductive elimination since the carbon iodide and the carbon oxygen bond have been broken. So, for a reductive elimination, we need a reducing agent. What could that be? For instance, magnesium. If we would form a Grignard reagent here, then an elimination could take place easily. However, a Grignard reagent here could induce intermolecular reactions with other ester moieties. Therefore, it is better to choose zinc as the reducing metal because organic zinc molecules have a high functional group tolerance. So, let's try zinc usually as powder. Then this organozinc compound will be formed. And the elimination will proceed to form the zinc carboxylate and finally we just need to hydrolyze under moderate, slightly acidic conditions, and then we will get to the target molecule. Thanks for listening.